So we need to prove the following. So we'll begin our problem from the left hand side. So here we have cosine theta divided by 1 minus sine theta. So let's do one thing. We know that cosine of 2 theta, that's given by cosine squared theta minus sine squared theta. But in our case here, we need cosine theta. That's the trigonometric ratio of a submultiple angle, submultiple of 2 theta. So what we'll do, we have taken half of this angle 2 theta. So we'll have to take the half of the angle on the right hand side as well. So this will become cosine squared theta over 2 minus sine squared theta over 2. We're going to replace cosine theta with this expression into the numerator. Then coming to the denominator portion, we have sine theta. Now we know sine 2 theta, that's 2 times sine theta times cosine theta, which means that sine theta will be equivalent to 2 times sine theta over 2 multiplied to cosine of theta over 2. We're going to substitute these values. So we have, in place of cosine squared theta, we're going to get cosine squared theta over 2 minus sine squared theta over 2 whole divided by 1 minus 2 times sine theta over 2 multiplied to cosine of theta over 2. Now we have cosine squared theta over 2 minus sine squared theta over 2 in the numerator. That's the difference of two squares, a squared minus b squared, which is simply the product of a plus b times a minus b. In our case, we can rewrite the numerator portion as cosine of theta over 2 added to sine of the angle theta over 2. This will get multiplied to cosine of the angle theta over 2 minus sine of the angle theta over 2 whole divided by, now what we'll do, we will manipulate this one. Now 1 can be also written as sine squared theta over 2 plus cosine squared theta over 2. We know that's the identity. So sine squared some angle plus cosine squared the same angle, that's always equals to 1. Minus we have 2 times sine theta over 2 multiplied to cosine theta over 2. Now there's immediately we can rewrite the denominator. So let's write the numerator part first. So we have cosine of theta over 2 added to sine of the angle theta over 2 multiplied to cosine of the angle theta over 2 minus sine of the angle theta over 2. So what we have in the denominator is a squared plus b squared minus 2 times ab. So that's nothing but a minus b whole squared. So in our case, we will consider it to be cosine of theta over 2 minus sine of theta over 2 whole square. So when we expand this, we are going to get the previous expression as obtained in the denominator. Now, luckily for us, what we can do is we can factor out 1 cosine theta over 2 minus sine theta over 2 from both the numerator and 1 from the denominator. So that leaves us with cosine of theta over 2 added to sine of the angle theta over 2 whole divided by cosine of the angle theta over 2 minus sine of the angle theta over 2. But this is not the expression on the right hand side. Here we need a tangent function. So what we'll do, we will divide both numerator and the denominator with cosine of theta over 2. So let's do that. So we'll take the numerator and we're going to divide it with cosine of theta over 2. So we'll have to do that to the denominator part as well. We'll take the denominator cosine theta over 2 minus sine theta over 2 and divide it with cosine of theta over 2. In doing so, we'll find that the first term will become 1 in the numerator and the second term will become tangent of theta over 2. Similarly, in the denominator, the first term will be 1, then we have negative, and we have the second term given by negative tangent of theta over 2. Now here, we are going to use a fact here. We know that the tangent of pi over 4 radians, that always amounts up to 1. So what we'll do, we'll use this in place of 1 in the numerator. So we have tangent of pi over 4 added to tangent of theta over 2 whole divided by, we have 1 minus tangent of theta over 2. Now tangent of theta over 2 can be also written as tangent of theta over 2 times 1, so that we can replace this 1 with tangent of pi over 4. Now from here we know that whenever we have we know for a fact that if we have tangent of some angle A minus tangent of some other angle B divided by 1, now this is plus here, minus tangent of A times tangent of B, so that's nothing but tangent of the angle A plus B. Now in our case, A corresponds to pi over 4 and B corresponds to theta over 2. So when we use this formula, then we are finally going to get tangent of A, so A will be pi over 4 added to B, so B is theta over 2, and this is exactly the expression on the right hand side. So let's check. We needed tangent of pi over 4 plus theta over 2. Yes. So we have successfully proved the problem. However, this is not the only way. There are multiple ways to verify the given equation. So let's go to another method. So here what we'll do, we'll again start from the left hand side. So here we have cosine of angle theta divided by 1 minus sine of angle theta. So what we'll do, we'll convert this cosine function to a sine function and the sine function to a cosine function. To do that, we're going to use the fact that cosine of theta was equivalent to sine of the angle pi over 2 minus theta. And if we start with sine theta, then this can be expressed in terms of the cosine function as cosine of pi over 2 minus theta. So let's substitute our values here. So we get sine of the angle pi over 2 minus theta divided by 1 minus cosine of the angle pi over 2 minus theta. So here for the time being, let's assume that pi over 2 minus theta is equivalent to phi. So that means our expression becomes sine phi divided by 1 minus cosine of the angle phi. Okay, now we know that we have already talked about this. So sine phi can be expressed as 2 times sine of the angle phi over 2 times cosine of the angle phi over 2. And if we take 1 minus cosine of phi, so this will become equals to 2 times sine squared phi over 2. So let's use these values. So we are going to get 2 times sine of the angle phi over 2 multiplied to cosine of the angle phi over 2 divided by, in the denominator we have 2 times sine squared phi over 2. Now we can factor out 1 2 from the numerator and the denominator, and we can also factor out 1 sine phi over 2 from both the numerator and the denominator. So that leaves us with cosine of the angle phi over 2 divided by sine of the angle phi over 2. Now what's the ratio cosine over sine? That's nothing but the cotangent function. We have cotangent of phi over 2. But as we can see here, we need a tangent function. We don't need a cotangent function. But there's a relation. So if we have cotangent function, so that can be expressed in terms of the tangent function as tangent of pi over 2 minus phi over 2. Fine. Now let's replace the value of phi with pi over 2 minus theta. So we were going to get, now we have equals to tangent of pi over 2 minus, now phi over 2 is going to become pi over 4 plus theta over 2. All we're doing is dividing this expression both sides with 2, which will be equals to tangent of, now pi over 2 minus pi over 4, that's simply pi over 4 added to theta over 2, and this is the expression on the right hand side. So we have successfully showed that the left hand side equals to right hand side. So here I have showed 2 different methods to verify the given trigonometric equation, and there are also different ways, and if you could think of any other ways to verify the following equation, do share your ideas in the comment section.